Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we are going to make introduction about Unit 1, Physics Edexcel AS, inshallah. We are going to start from fundamental quantities and units, then we'll go to talk about motion with forces. First of all, we have several fundamental units. One of them is the mass, and the unit of it's supposed to be in kilograms, the mass, M, and its unit, it will be kilogram, and the length or the distance, okay, L or S, okay, and the unit of it's supposed to be in meters. Then we'll talk about the time. They use small letter T to represent it, and the unit of it is seconds, the basic unit, okay, I'm not talking about minutes or hours, okay. Then we'll talk about electric current. They use letter I to represent it, and the main unit of it is ampere, okay. Then the temperature, they use letter capital T to represent it, okay. And the unit of the basic, the fundamental unit for it, it's Kelvin, K, not degrees Celsius. And we are going to talk about the amount of substance. How much is the substance? Okay, amount of matter, amount of substance. And they use letter N to represent it, and usually they are talking about moles, how many moles that the object has, okay. And finally, we are going to talk about the light intensity or the luminosity, luminosity or luminous, okay. And they use what letter I and curve I or I italic I, okay, luminosity. Okay, and the unit of it is candela, CD. Okay, in the Edexcel, IGC in the Edexcel, okay, unit 1, they are usually in unit 1 they ask about the mass, the length, the time. Okay, maybe in A2 they ask about what current. Sometimes they ask about temperature as a multiple choice question. So mainly they ask about the first three, okay, or I told you the 4-1, okay, mass, length, time, and sometimes temperature, okay, as a multiple choice question. But in unit 2, they ask about the first three with what? With a current. That's the first thing about the fundamental units. So how do they ask questions? Yeah, for example, we have to know that we have something called drive unit. Like what? Like, for example, we know that force, the unit of it is what? Is a Newton. And that means what? If the force, the formula for it is mass multiplied by acceleration, that means the Newton, which is the drive unit, it's come from a base fundamental unit of mass and the acceleration. What's the unit of mass? We just write it down here, which is what? The mass in kilograms. And you know from the IGCSE that the acceleration is meters per second what? Square. So kilogram dot meter per dot second -2, all of this is equivalent to something called what? A Newton. That's one of the questions that they can ask about it. Another question that they can ask about it is, for example, what is the fundamental unit or what's the base unit of the work, which is joule. This is joule is the drive unit. And we know that work, energy, kinetic energy, potential energy, what forms of energy, okay, and work, all of them, they have the same unit, which is what? Which is joule. Okay, it's equal to force multiplied by what? Distance. And we just find that the value of the base unit of the force, which is what? Mass times acceleration, which is kilogram dot meter per second square. All this is in Newton multiplied by the distance, which is in meters. So that leads us that joule, it will be equal to kilogram dot meter square per second what? Square, and etc. We have a lot of drive unit that we have to know how to convert it into what? Into base fundamental units, like Pascal, the pressure, okay, like later on we'll talk about currents, okay, and charges, okay, when we talk about voltage, when we talk about resistance, okay, every time, like when we talk about power, exactly. Thank you for your practice here, okay. Every time you give, they ask about something, they ask you to bring a question, how they, for example, multiple choice question or written part question, 1 to maximum 3 marks to show the unit or show that it doesn't have unit or what is the base unit of this symbol or this value, okay? That's the first thing that we have to know it. The other thing that we have to know it is the prefixes. Who can tell me what is the prefixes? What is the prefixes? We know that we have something called prefixes, and the prefixes is what? Is a small letter, they put it in front of any value or any number, okay, to tell me how big or small is the value. Yeah, for example, we know that we have something called what? We have something called what? In a kilogram, kilo Newton, kilojoule. So what's the meaning of kilo? Megawatt, mega ampere. What's the meaning of mega? Milligram, millimeter, millisecond. What's the meaning of milli? All these are what are prefixes, and we have many free prefixes. We have to know them, and we have to know how to convert them. For example, I will put them in order approximately. We have milli, we have micro, then nano, then pico. These are the small letters for things that are much smaller than ordinary value. And we have the opposite, kilo and mega and giga and tera. Okay, also these values, they what show you how big is the number. And there's one else here, okay, which is what? Centi, cent. Now, the first one, which we know it from maybe fourth grade, that it's the centimeter. When they said centimeter, centisecond, centigram, what the meaning of centi? Centi came from the word cent. Who can tell me how many cent in $1? Yes, thank you. How many? Exactly, thank you. On the chat, you can send it on the chat. How many cent in $1? There is 100 cent. That means if I want to convert from centimeter to meter, I will divide by 100. That means I'll multiply by 10 to the power of what? Negative what? Negative 2. Okay, that's for what? Centi. But the rest of these prefixes, you will see that they are a multiple of 3s. For example, millimeter. What the meaning of millimeter? Divide by how much? Excellent. شكرا. شكرا يا أنفال وشكرا يا محمد. Millimeter. When we said millimeter, that means divide by how much? Bravo. By 1,000. So what the meaning of 1,000? I multiply by 10 to the power of negative what? 3. Micro, it will be times 10 to the power of negative 6. Nano, from word 9, times 10 to the power of negative 9. And pico, times 10 to the power of negative 12. Okay, these prefixes, you have to know them, okay, before you go to unit 1 or unit 2. Okay, on the other hand, we have something called what? The kilo and mega and giga and tera. Kilo, it's a big value, which is 10 to the power of 3 zeros. It's 1,000. Mega means a million. That means it will be multiplied by 10 to the power of 6. And giga means a billion times 10 to the power of 9. And tera times 10 to the power of 12. As you can see, the values, they increase or decrease by 3, by 3, by 3, by 3 zeros, okay, except what? Centimeter. These are the most important prefixes that you have to know how to convert them when they put any value or any number in your question, okay? So let's go directly to questions. I will show you they bring a maximum 1 or 2 or 3 marks, okay, on prefixes, and maximum 4 or 5 marks on what? On the prefixes. Okay, so the base unit or the fundamental unit, they bring questions about it, approximately 1 multiple choice question in the whole paper, or maximum 3 marks, as we're going to see. The prefixes, they keep repeating it between 4, 5, 6 marks in the whole exam. You have to know how to convert values. Okay, first question. You have this worksheet, okay? I think it is sent to you with a link, okay? If you don't have it, you can send it to me on the chat, and I'll send it back to you, no problem. But not now, after the session, okay? After the class. The table shows some physical quantities, which row identify scalar and vector quantity. Since you know from the IGCSE that vector quantities, they have what? What do they have? Exactly, they have direction. So which one is the correct answer here? Thank you, Kareem. Who else? Is the scalar, is the distance scalar? Yes. Is the time scalar? Yes. Is the velocity scalar? No. Is the work scalar? Yes. Okay. Is the velocity, the acceleration vector? Yes. Is the speed vector? No. Is the force vector? Yes. Is it the power a vector quantity? No. So which one is the correct answer? It's A. And you know that in these type of exams, they put you a small square that has a cross in it here. For example, if I did a mistake and I put a cross here like this, okay, and I want to change the answer from C to A, I'll put a horizontal line like this to cancel it. Then I'll put what the cross here in on A on the what multiple choice questions, because it's an infrared detector that detects the answer, okay, not a human being. Okay, easy question. شكرا للشباب الصبايا اللي جاوبوا. Okay, number 2. Which of these units is the same as in Newton? Newton is the force. So force is kilogram, okay, because it's mass. It's a mass multiplied by the acceleration. So it's kilogram multiplied by what? Meters per second square. Where I can find this, which one is the correct answer? It's B. Thank you for the student that they practice. So the answer, so the answer is what? Is B. Good. طيب. Question number 3, I'll give you a minute to give me the answer on the chat. Which set of quantities all scalar? Yeah, send me the answer on the chat if you please. شكرا. Yes. تمام. Good. If you please check your answer. One of you gave me wrong answer. Okay. Good. Excellent. Excellent. We have a new students here. Ghazi, Saja. Yes. Okay. Excellent. Good. So you can see that these are, as you can see, I wrote here the code that and the year that they bring the question. All scalar, you can see that the acceleration and the displacement and velocity, they are vector, vector, vector. And the same thing here, when we have force, okay, it's a vector. Here we have weight, which is vector. So which one is the correct answer? The answer is what? Is B. Thank for all the students that they practice and give me the correct answer. And even if it's not correct. So the answer of question 3 is B. Now the rest of these questions, okay, I want from you, okay, any question that we didn't do it, I want from you to try to do it and send me the answer to check if it's correct or not for the class next time, inshallah. Or you can send me on the group on the WhatsApp on my private number. Okay. One of the questions, this one, it's a part of a whole question about the wind energy, how it converted to kinetic energy, then to electrical energy. Okay, with a certain efficiency. We are going to talk about that later. Okay, what they ask. The following figure shows a turbine that is used to generate electricity, electrical power, from the wind. The power P available from the wind is given by what? By this formula. Power equals C L rho V. C L square rho V cube. Okay. These papers, you can, the person who send you the link, ask him to send you the paper, because the same link and the same paper, you can find it on my channel, okay, on Telegram, okay, or on my groups, on the WhatsApp groups. I have many. Yes, you are welcome. Okay, you can have my number. Okay, you can see my number here. It's written. It's 962 79982 8524. Okay, this is my number. This is the code of Jordan. This is the code of the company, and this is the number. Okay, let's do this question. What they ask, where L is the length of each blade, okay, rho is the density of the air, V is this wind speed, and C is a constant. Show that this C has no unit. Now, every time they give us a formula, this formula is supposed to be homogeneous. What's the meaning of homogeneous? Homogeneous means that the right side and the left side of the equation have, both of them, they have same unit. They have what? Same unit. So let's check what are the units here. So what is the unit, the base unit of the power? We know that power is watt, right? and watt means joule per what? Per second. And joule is a Newton dot meter, force times distance, okay, per second. And we know that in Newton is kilogram dot meter per second square multiplied by meter per second. Good. So again, watt is the unit of power, and power is energy per second, or joule per second, or work per second. And joule is the work, okay, which is Newton dot meter. And in Newton is what? Kilogram times what? Mass per second square, which is mass times acceleration, multiplied by mass, multiplied by second. All of this, okay, supposed to be equal to the other side, to the right side. The right side is C, that we are going to show them with the 3 marks. It's unitless, it doesn't have any unit, okay? Multiplied by what? Multiplied by the length square. The length is supposed to be in meters, so meter square. Multiplied by the density, and we know that the density, it's kilogram per cubic meter. Multiplied by what? The speed, which is meter per second, and this we have to what? Put it cube. So let's fix this again here. So C multiplied by meter times per meter to the -3, that means meter -1, multiplied by kilogram, multiplied by what? Meter per second cube, which is meter cube per second what? Cube, okay? So let me fix this one. So C times kilogram dot meter square per second cube. Is it the same as this one? Kilogram dot meter square per second cube. This is the base unit of watt, of the power, okay? And it's equal to the other side. So since they are equal, both sides, both units, that means they cancel out each other. So C is unitless, has no unit, unitless. It's a constant value. Like when we talk about kinetic energy equal half mv square, half is a constant value, doesn't have a unit. Half times mass times velocity square, okay? Any question here? Is it clear? Yes, it's easy 3 marks. Yes, thank you. Yes, it's easy 3 marks. Good. Now let's move on to next idea, which is the motion and the movement, and how we can how we can describe the motion and what's the relationship. Okay, in this worksheet I put it in sideway because I have a lot of information that I want from you to understand it and to write it down. Okay, let me show it to you as a PowerPoint here. Hold on. Okay. Now look here, ya shabab. What do we have? When we talk about what? Motion with what? With forces. We are talking about certain type of what? Of information that you have to know it in details. What are these details that you have to know them? First of all, in any motion, we have what? The opposite of motion, stationary. That means the object doesn't move, it is at rest. Okay? So we have motion, movement, and we have stationary, doesn't move at all. Okay, we have to know what the relationship between any forces with motion, or how we can describe the motion, okay, and how we can describe the stationary object and what are the forces act on it. And we know that for motion, okay, we have uniform motion that is constant, doesn't change, or we have what? Non-uniform motion. And usually in non-uniform motion, they give us graphs and they ask to estimate informations from the graphs. They ask us to estimate information from graphs. And as you know, we have several types of graphs. Okay, we have displacement time graph, displacement S time graph. We have velocity, and talking about positive and negative here. We have positive and negative, forward and backward, right and left, the same thing. Velocity forward and velocity negative, time graph. And we have what? Acceleration what? Time graph. Okay, now usually they give us these type of graphs, and they ask about it a lot of questions. So whenever they give us displacement time graph and they ask about the speed or the velocity, okay, what I'm going to find out, who can tell me? Excellent, I will find what? The gradient. Bravo. So again, whenever I have distance over time, which is the velocity, whenever I have a graph and for example, this is the graph, I have to find the gradient of it to find how much is the velocity. Yes, which is the slope, exactly. But if I have velocity time graph, and they ask about the displacement or the distance covered, what I'm going to find, bravo, I'm going to find what? Area under the graph. I'm going to find what? The area under the graph. So again, if I have velocity time graph, I can find the distance by finding the area under the graph, okay, this area under the graph. But if I have what? Distance time graph and I want to find the speed, I will find the slope, the rise over the run here. Yes, Fadal Salman, you raise your hand. Go on. What's your question? Yes, what is your question? Send me on the chat if you please. I can't. Okay, send me on the chat. What's your question? Okay. طيب, let's move on. Okay. So again, what do we have here? If I have what also, يا شباب, if I have velocity time graph and they ask about the acceleration, what I can do, I can also find what? The gradient, since the acceleration equal to change in velocity divided by time. So the gradient of the line divided by the time is what? The acceleration. And finally, if they give us acceleration time graph and they ask about the change in velocity, delta V, V minus U, I will find the what? The area under what? Under what? Under the graph. So usually in non-uniform motion, they ask us to estimate the motion and there is range of the accepted answer. Your question, in a test, I received 2 triangles and told me to find the distance for both of them. What should I do? You find the area under the graph. Yes, we're going to talk about that in details. There's a question about that. Okay, that's about non-uniform motion. But if we are talking about uniform motion, okay, we are going to talk about other things like what? We have straight line motion or we have curved motion. In curved motion, we have 2 types of motion, okay? We have circular motion, which is not included in our syllabus, okay? And we have what? Projectile, which is a very important thing that they keep repeating questions about it. Every year they bring at least one question about it, one huge question about projectile, okay? Okay, so that's about curved motion. And for uniform motion, we have circular motion, not included in our syllabus, and projectile motion, which is very important. We are going to explain it later on. And also in a straight line motion, what do we have? We have a steady velocity, constant speed. And you look, I use the word velocity because both direction and what speed are constant, okay? So that means we have only one formula for this type of questions that you studied since 4th grade. The velocity equal distance divided by what? Divided by time. This is the only formula that I'm going to use it when they are constant speed or constant velocity. And the other type of linear uniform motion is uniform what? Acceleration. We know that acceleration equal what? V minus U divided by what? Divided by time. This is the basic formula that I'm going to use it about when there is what? Linear acceleration. But actually, we have 5 equations, okay, in uniform acceleration. And these 5 equations, you have to know them before you go to the externals, okay? 3 of them, it's written in the back of the exam, but it's not, you have to memorize them and you have to know how to use them, okay? What are the equations? First equation is the same as this equation, acceleration equal v minus u over t, but I have to put it in terms of v. I make the v the subject of the formula. So v equal u plus at. This is the first equation. Second equation, v square equal u square plus 2as. Third equation, s equal ut plus half at squared. Fourth equation, similar to this one, but with v. So displacement equal vt minus, because this is final velocity, that's why I put minus, but if it's initial velocity, I will add the motion with acceleration, okay, minus half at squared. And finally, s equal the average speed, which is u plus v over 2, that's the average speed, multiplied by what? By t. As you can see, these are the 5 equations that we have to know them when there's, and use them when there's what? Constant acceleration, and I cannot use velocity equals speed over time when there's acceleration. So these equations, as you know, this is the first, the second, third, okay, the fourth. Who noticed something about this equation? And this is the fifth, okay. Who noticed something about this equation? Look here. In each equation, we have what? 4 variables. Look here. V, U, A, T, 4 variables. V, U, A, S, 4 variables. S, U, T, written in both sides. Acceleration, also 4 variables. That means in each question, at least they have to give you 3 given and ask about the 4th equation, the 4th unknown, okay? So here, the first equation that has no displacement, that's why they call it no displacement or no S equation. And this equation, they call it no time equation, doesn't have time. And that's a trick. If you know this, that they didn't mention the time, that means I will use this equation, okay? This equation, they call it no V equation. And the same thing here, no U equation. And finally, no A equation. These equations, they have to know them when you are going to the externs and you try to answer any past paper questions. Okay, so far we didn't finish here. What do we have here also? Any object which is stationary at rest, or any object which is at constant velocity, at steady velocity, what we call these 2 different motion situations, what we call them? We call them by a certain word which is very famous for you since you are finishing, you are done by the IGCSE syllabus. What is the word here? Yes, who can tell me what is the word? Yes, it is balanced. Balance. So any balanced object, that means it can be at rest, stationary, or it can be at what? At constant velocity. So what do I mean by rest, balanced object? What do I mean when we say there is a balanced object? That means this balanced object has a resultant force equal how much? Any object at rest or any object at constant velocity, how much the resultant force on it is equal? Bravo, Saja. It's equal to 0. It's equal to what? To 0. Who else send me the answer? Yes, Samar. Thank you. It's equal to 0. This is Newton's first law of motion. This is Newton's first law of motion. We are going to explain it in details. What about the rest of these laws? The rest of these laws talk about in Newton all of this: curved motion, projectile, uniform acceleration, graphs. All these, they are talking about Newton's second law of motion. Who can tell me what is Newton's second law of motion state? What's the formula for it? Here, the resultant force equals 0. This is the Newton's law of motion. They say that the resultant force equal what? 0 for balanced object. What in Newton's second law state? That what? Yes, thank you, Ghazi. Well, thank you, Samir, that the resultant force exactly equal what? Mass times acceleration. The most important formula that you are going to study it in the unit 1 IGCSE, resultant force equal mass multiplied by what? Acceleration. So this is the Newton's first law, and this is Newton's second law. Newton's first law talks about only any object at rest or any object at constant velocity, but Newton's second law talks about everything else, okay, about all these other situations, okay? I'm not going to scratch on my paper, but you have to know that we are talking about everything else. And finally, we have something called Newton's third law that includes everything. Newton's third law talks about what? Newton's third law of motion talks about what? Yes, who can send me the chat? Yes, exactly. It talks about what? Newton's third law of motion. Another answer, another answer. It talks about for every what? Exactly. For every action, there is an equal opposite reaction. For every action, there is an equal opposite. Opposite in what? Opposite in direction, what? Reaction. We are going to talk about that in details. You can take a screenshot of this mind map, and this mind map tell me everything that we are going to talk about it during the few classes later, okay? The introduction about unit 1 physics, okay? Because all the questions, they have to give you a specific word: acceleration, graph, steady speed, balance. These words, you have to know them, where we have to look, okay, what is the formula that we have to use, what is the law that we are applying, and that's it, okay? Tamam? Okay, you can write this down on this worksheet. Let's move on. What do we mean by speed, and what do we mean by velocity, and what's the differences between speed and velocity? Yes, who can tell me which one is a scalar and which one is vector? Yes, who can tell me which one is a scalar and which one is vector? Speed is a scalar, thank you, while velocity is what? Is vector. So what do we have to know? Whenever I put the tick, that means we have to know to memorize the definition. So speed is distance covered per time, distance covered per time, per 1 second, while velocity is what? Is it distance covered per time or displacement? Aha. Since we talk about distance and displacement, that means distance has no direction, while displacement has what? Direction. Displacement covered per time. And both of them, as you know, both of them, they have the same formula, but different use of the formula. So this is a scalar, and this is what? Vector. Okay? So velocity equal distance divided by time. Now, you know that the distance is supposed to be in what? What is the unit of distance? The unit of distance can be in what? Can be exactly in meters, or can be in what? Can be in meters, or can be in what? In kilometers. Excellent. While the time, it can be in what? Can be in seconds or minutes, or it can be in what? In hours. So that means we have several units for speed. One of them is meters per second, and the other is what? Kilometers per hour. Usually I ask my student this tricky question, and a lot of them, they don't know the answer unless they study it or they heard from their teacher. Which unit is bigger? Which unit is bigger? Meters per second or kilometer per hour? So for example, if I'm driving my car at 20 meters per second, is it faster, or at 20 kilometer per hour, it's faster? Which unit is faster? Send me on the chat. Which unit is faster? Meters per second or kilometer per hour? Some of you send me that both are same. Some of you send me kilometer per hour is bigger because it's kilometer. Okay, some of you send me meters per second. Actually, if you have a calculator, okay, and you want to convert from 1 meters per second into kilometer per hour, it will be 3.6. How come, Ustad? Now look, if I want to convert 1 meter to kilometer, I will divide by how much? Exactly, I will divide by 1,000. But if I want to convert 1 second to 1 hour, I'll divide by how much? 60 and 60, yes, which is how much? 60 and 60, 120, 60 and 60. 60 times 60, yes, exactly, 3,600, bravo. So 1 over 1,000 divided by 1 over 3,600, it will be 3.6. That means 1 meters per second is what? Is equal to 3.6. So meters per second is bigger unit. Okay? طيب, let's do this small example السريع عشان ايش نستوعب اكثر. We will understand and realize the differences between speed and velocity meters per second and kilometer per hour. A car covers 36 kilometer in half hour. They give us the distance and they give us the time. Find out the average speed. Why they say the word speed, not velocity? Why they say the word speed, not velocity? Excellent. Why? Another answer? Because they didn't mention what? Direction. And maybe the direction changes during the 36 kilometers. It doesn't keep moving in a straight line. Exactly. There's no displacement. There's no direction. Exactly. Why they use the word average? Why they use average speed? Why did they say find out the speed of the car? Why they say the word average? You get confused in the exam if you don't know why they use this word or this word. Okay, because I'm talking about what? About approximately the same speed, which is constant if the distance, if the whole motion, the whole journey was constant, the speed. But during 36 kilometers, maybe there's traffic, he slows down, maybe it's a highway, speeds up, maybe there's something that reduces the speed or increases speed. That's why they use the word average what speed. So in both ways, I need to find the speed or the average speed in kilometers per hour or in meters per second. So speed equal distance over time or displacement over time, which is 36 divided by half. And by using the calculator, it will be how much? 72 kilometers per hour. Yes, you use your calculator. Okay, no problem. 36 divided by half, it's 72 what? Kilometers per hour. But if I want to convert it into meters per second, okay, it will be something else here. So distance or displacement divided by time, so it's 36 over half hour, 36 kilometers. I have to convert it into meters. I will multiply it by how much? Exactly, I'll multiply by 1,000. And half hour, which is multiplied by 60 and 60, which is 3,600. And by using the calculator, our final answer, it will be how much? 20, exactly, 20 what? Meters per second. Okay, check your calculator if you please. Some of you send me the wrong answer. No, it's 20 meters per second. Please put brackets or make fraction of using the calculator. Now, who can tell me which one is bigger? Which one is faster? 20 meters per second or 72 kilometers per hour? Yeah, send me the answer on the chat. Which one is faster? 20 meters per second or 72 kilometers per hour? Some of you send me meters per second. Some of you tell me kilometer per hour. Some of you, Actually, we are talking about the same car, but different units. So both of these values, they are what? They are the same. Like I'm saying, for example, 20 meters per second, it's equal to 72 kilometers per hour. Like when I'm saying $100, it's equal to how much? 70 Jordanian dinar or 500 dirham Emirati or مش عارف, maybe 35 Kuwaitian dinar or 30,000 جنيه مصري, okay, Egyptian pound, okay. So I'm talking about the same value but different units, okay. تمام. Excellent. شكرا يا سجا. سجا send us that 20 meters per second multiplied by 3.6 will be 72 kilometers per hour. Excellent يا سجا. برافو عليك. Okay. Now let's move on and talk about another word that we have to know the definition of it, which is what? The acceleration. Do they bring define acceleration, define velocity? Yes, few marks. We need these few marks because every time the curve or the boundary for the unit 1 out of 80, maybe it will be 53 out of 80. So that's the A. The B, okay, it will be, for example, 49 out of 80. So we need each mark to get A, not B, to get high A. And eventually we get, for full physics, we get what? A star, inshallah. Okay? So you have to be careful. Okay. So what's the definition of acceleration? The definition of acceleration is 5 words. The rate of changing velocity. Without mentioning changing, you will not get the mark because it's only 1 mark. The rate of changing velocity. The rate means per second, per time. Yes. The rate of changing what? Velocity. And why I use the word velocity, not speed? Why I use the words velocity, not speed? Because acceleration has 3 meanings, as you know from the IGCSE. Acceleration has 3 meanings. What are these 3 meanings? These 3 meanings are speeding up, slowing down, and change direction of motion. Change direction of motion. Now, speeding up, as all of us knows, it's what the normal acceleration, which is positive. Slowing down, which is the negative, and they call it what? Deceleration or retardation, yes, deceleration, okay. And change direction of motion, we are not going to study that's in what? In curve motion, okay, like circular motion. We're not going to study it now, okay. So from this, we know that acceleration equal what? V minus u divided by t as a formula, and the other 5 equations that you have to know them, okay? You have to know these other 5 equations, and you have to know the first 3, okay, in details, how you are going to use them to write down and to answer the question, okay? Any questions so far? Clear? طيب تمام. Now let's move on. If we want to describe the motion, okay, by graphs, okay, we have several types of graphs. As I told you before, we have distance or displacement time graph, and we have speed or velocity time graph, and also we have what? Acceleration time graph. So let's start the small things, then we go to the details with more heavy questions and large ideas, okay? So for example, if this line is horizontal and it's on the x-axis, what this represents? This will represent an object at what? Bravo, at rest or stationary. Excellent, bravo. So at rest or stationary. Okay, what about this line? It's also horizontal, but it's not on the x-axis. What does it represent? A constant speed? No, it's not at constant speed. It's distance time graph. Excellent. Yes, it is at rest also. Instead, both of them, they are at rest. Yes, because the distance here was 0, 0, 0 during the time. But the distance here, for example, 5, it remains 5, 5, 5 remains during the time. So it doesn't change, it doesn't move. So this object is at rest 0 meter far, and this one is at rest 5 meter far. Okay, so you have to be careful about this. Okay, you finish IGCSE, these things, they have to be easy. Yes. What about this line? Okay, what does it represent? What about this line? What does it represent? Excellent. This object at steady speed. At steady what? Speed or steady velocity. Yes, steady speed. I said speed because I don't have direction. It's not displacement. At steady speed or constant speed. Okay, and this one, exactly. Also at steady speed. So what are the main difference between the first one and the second one? Both of them are at steady speed. But this one is moving away at steady speed, moving away or moving forwards. But this one is moving backwards, okay? So if I want to write this here, I will write at steady speed forwards, okay? Because the distance is moving away, it's getting further, okay? But this one is moving what? Backward, at constant speed backward, because it's approaching to us, the distance getting closer. And who can remind me how we can find the speed? How we can find the speed in both graphs? By finding what? This one or this one? By finding what? Exactly, by finding the gradients. Excellent. by finding what? The gradients. So the speed in both ways, I can find them by finding what? The gradients, okay? Now we was talking about straight lines. Now what about if the curve, if it wasn't straight line, if it was curved like this one? Who can tell me this object that the curve is going with increasing gradient, the gradient increases, okay? Or the gradient decreasing. Is this means the speed is constant? No, thank you. في ناس كاتبين لي positive, negative, في ناس كاتبين لي increasing, كاتبين لي decreasing. Aha. It is acceleration or deceleration. Why? Because the gradient keep increasing or the gradient keep decreasing. That means the speed here increases or the speed here decreases. But it's not necessarily to be constant acceleration or constant deceleration. It's not uniform. We don't know. We don't know unless it is a straight line or they tell us in the question, or I do calculations to check if it was a uniform or constant acceleration, okay? So here, because they give us gradient, okay, which is increasing gradients, I can say it's on acceleration. On acceleration, how do I know that there is acceleration? Because there is increasing gradient, okay? And here, what on deceleration, bravo. Why not constant? Because I don't know, I don't have enough information on deceleration. Why? Because it's decreasing gradient, decreasing gradient. So if I have acceleration or deceleration in both situations, and they ask about the speed at certain moment, yeah, for example, if they ask the speed at this time, what I can do, usually the student do this mistake. They find how much is the distance and okay, and they divide it by the time, and that's it. Allah ya'tikum al-afiyah. No, that's not correct. What I have to do to find the speed at this moment, what I have to find. You finish IGCSE, you have to know. What I have to do to find the speed at this moment. Yes, exactly. I have to draw a tangent. I have to draw what? A tangent and find what? Exactly, find it's what the speed. That's why I told you there is estimation approximately. So to find the speed at any moment, we draw what? A tangent and find its gradient. Its gradient. Okay, the same thing here. If I want to find the velocity here, I'll draw a tangent at this point and I will find how much is the gradient of this. I'll take two coordinates whenever the points are further. Okay, it will be more accurate to find the points here, and okay, whenever the line is longer, I will be more accurate. Longer line means accurate. Okay, any questions so far? Good, let's move on. Here, what do we have? We have the same thing, but it's not distance time graph, it's a speed time graph. Okay, so you are going to help me to what? To give me the description of each one of these graphs and how we are going to use this information and data to find other informations from the graph. Because for all the graphs in physics, in chemistry, in biology, in economic, even when you are going to study marketing, all the graphs, we have four things that we can find out. The data from the XY axis, okay? The description, directly proportional, inversely proportional, increases, decreases exponentially, okay? The gradient and the area under the graph. The gradient at a certain point or the gradient of the line and what? The area under the graph. These are the four things that they ask about it in any graphs, okay? The XY coordinate, what is the value of that? What's the value of this, okay? The description is the relationship directly proportional, inversely proportional, exponential, whatever it is, okay? Find out the gradient, okay? How much is the slope of the line to find other informations, and what's the area under the graph represent, or how we can find it out, okay? Now, let's move on. For this line, who can tell me in a speed time graph? في واحد يا سامر بعت لي الأجوبة لهم كلهم. شكرا يا سامر. سامر بعت لي الفيرست والسكند. اوكي تمام. ثيرد تمام. Look, Samir, I will not give you the answers, but you did a lot of mistakes. Okay, you have to be careful. This is a speed time graph, not distance time graph. Okay, how do I draw a tangent? By ruler. Okay, we are going to show you on a question. We are going to show you later, in a few minutes. Okay, now, first one is at rest. Exactly. First one is at rest. It's stationary. There is no motion. It's a horizontal line with a speed 0 and remains 0. So it's at rest. But second one, it is at what? At steady speed. There is a speed and there is a value of the speed and remains constant. At steady what? Speed. So because this first one here, is it at rest? That means the displacement or the distance covered is 0. And also the acceleration is what? Is 0. There's no acceleration and there's no displacement. But this one, because it's a steady speed, the acceleration is 0. But how can we find the distance? Some of you send me speed times time. No, I want the four things that I'm going to say. By finding exactly the area under the graph. So by finding the area, which is speed times time, I can find what? The distance. So speed equals speed, distance equals speed times time. We know that, okay? Because it's constant speed. Bravo, okay? But we have to know that whenever we have a graph, we have to use the gradient or we have to use the area under the graph. So in this situation, because I'm talking about constant speed, okay, the area under the graph, it's what? It's the distance covered, okay? Which is velocity times time or speed times time, okay? If I have values, I will give you numbers, but I don't have values now here, okay? Next, number 3 here, because it's going up, that means the speed increasing, and this is a straight line, that means uniform what? Excellent, uniform acceleration. Who can tell me how much is the acceleration here? Exactly, who can tell me how can we find the acceleration? By finding what? Bravo, by finding the gradient. By finding the gradient, how much the rise, how much the speed change divided by how long is the time. Excellent, bravo, excellent. But what about if I want to find what? The distance or the displacement. How can I find the distance here? Bravo, area under the graph. And this area under the graph is the area of that what? The right angle triangle here. Okay, this right angle triangle, I'll have to find the area, which is half base height. Bravo, excellent. Okay, fine. What about this one? Who can tell me? What about this one? Well, who can describe the motion? Is it uniform acceleration? Is it a straight line? It is uniform, but not acceleration, since the speed is decreasing. So it's uniform what? Exactly, uniform deceleration. Bravo, uniform deceleration. برافو. يعني في عندي ما شاء الله مروة، سجا، سامر، في كمان واحد اسمه محمد، كثير شباب اوكي عم بيبعثوا لي اجوبه، ما شاء الله عليكم، يعني رائعين جدا جدا جدا. اوكي برافو عليكم، الله يحفظكم يا رب. So uniform what? Deceleration, and I can find the deceleration also by finding what? By finding the gradient. Excellent. By finding what? The gradient. Okay, whenever I have the gradients, okay, I can find what? How much is the deceleration? Forget the negative sign, okay? And what about the distance? How much is the distance? How can we find the distance? The distance equal what? The area under the graph for this trapezium, okay? The area under the graph for the trapezium, A plus B over 2 times time, or times the thickness, or times width, okay? Or height. So here it's A plus B over 2 times T, okay? Or times H, sorry, times H. This formula, why I keep saying times T, because it's the same formula that we took it before. It's U plus V over 2 times time. That's why, yes, exactly. So you have to be careful that we have to know how to find the gradient and how to find the area of any object. Now, what about these lines? What do they represent? Okay, it's a curved line. It's not a straight line. So I can't say it's uniform. I can't say it's constant. I will only say uniform or constant if I have a straight line or when the question tells me. Yes, here we have a curved line. So what this curved line represents? This line does not represent deceleration. It's the speed keep increasing. So it's acceleration. The speed keep increasing. So it's acceleration. Yes, it's decreasing acceleration. There was a huge deceleration acceleration here in the beginning, but the acceleration after a while decreases. It's like dropping an object down with with air resistance. Eventually, to reach terminal velocity, there's no acceleration. So the acceleration decrease until it becomes zero, like terminal velocity, right? Okay. So here, this line, this solid line in the black, okay, it's what decreasing what acceleration. Okay, what about this one? What about this one? The gradient was steep and becomes less steep, huh? That means also what? Decreasing. Decreasing what? Excellent. Decreasing what? Deceleration, because the speed decreases. Decreasing deceleration. Let's give you other graphs, okay? Other drawing, okay? Who can tell me this line represent what? This blue line that I just draw represent what? The speed increases, yes. That's it. Increasing speed by what? Huh? Yes, it is acceleration, but is the acceleration has constant rate like this one? It's a straight line. Is it uniform acceleration? Excellent. Is increasing what? Acceleration. Bravo, bravo. Increasing acceleration. MashaAllah. What about this line, huh? Who can tell me? What about this line? Who can describe this line that's going down? The speed decreases, but it's not straight line, it's curved. And the line becomes more steep. Huh? What I'm going to say. Excellent, excellent. Huh? Another answer. Increasing deceleration. Bravo, bravo. Increasing deceleration. Okay. Now, it doesn't matter, okay, if it's increasing or decreasing deceleration. If I want to find how much the acceleration at this moment here, if I want to find the acceleration at this point, what I would do? Shall I take this value v with 0 and divide by the time? No, I will not do that. So what I will do? Exactly, I will draw a tangent. How I'll draw a tangent? I'll bring my ruler, try to touch only this point. Okay, and whenever I draw the tangent like this, I took farthest point from this line that I on the graph, and these points I will take the xy coordinate and find what? The gradient. That's how I can find what? The acceleration, by finding what? Gradient of the tangent. Gradient of the tangent. Type. Another question. Usually they ask find the distance. How can I find the distance? How can I find the whole distance? What I'm going to find? Exactly. If they ask about the distance, I will estimate the area under the graph. I'll divide it into squares or divide it into a large triangle with large trapezium. I will make any shape and try to find it out. It's not a quarter cycle, of course. Okay, but I will find the shape. I will divide it into several shapes. For example, this is a triangle. This is another trapezium. That is a third trapezium, and add the shapes. Okay, this shape plus this shape plus this shape together, and I will estimate my answer. Bravo. So if I want to find the distance in both graphs, okay, if I want to find the distance, I will estimate what? The area. So the same thing as here, the gradient. I'm estimating the gradient. Okay. How we are going to do that? Later on. Later on, I'll give you questions with values I want from you to answer. Okay. Now, let's move on, okay, to a question. Then we are going to return back to talk about forces and Newton's laws. Okay. If you have this worksheet, okay, If you please move on to our page where, hold on. Move on to page, where is it? Yes, to question 27, page 19. Question 27, page 19. If you have this worksheet, go to this page, okay? Page 19, question 27. Okay, look to the question, what they ask. The graph shows how the displacement, okay, varies with the time of an object that starts from what? From rest. That means u equals 0, okay, with constant what? Acceleration. They tell us that the acceleration is constant. Okay, even if it's curved, because it is a distance or displacement time graph. Okay, what they ask, use the distance time graph to determine the speed of the object at of the time 4 seconds. Yes, this is 4 seconds. نمسك هاي البوينت. Then what we will do? Yes, what will we do? Excellent. We draw what? We draw a tangent. يلا. Let's draw a tangent together. Okay, I want from you to draw a tangent. What I'm going to do, I'll draw a tangent. I will do it like this. Okay, hold on. Okay, discard. We're going like this. I'm sorry, I don't know what's happening. Okay, no problem, no problem. Yes, use your ruler if you please and draw a straight line that passes only this point. Use your ruler to draw a straight line that passes through this point. I have a software here, but I can't open it. There's something locked here in the laptop. Okay, if I have this application, I can draw by a ruler a straight line. Okay, let me try another application. Okay. Okay, let me try to use paint. Okay, I paint. This is a straight line, and this is straight line supposed to what? To pass only this point. Okay, as a tangent. Okay, tamam. When I draw this line, okay, I'll pick 2 points which they are what? Far from each other, and they are clear to take the gradients. Okay, so let's say that I will take this point and this point. Okay, for example, I'll take this point, the coordination of it 0, 2, 0, and I'll take what, for example, this point here. Whenever it's farther, I'll be more accurate. Okay, let's assume I'm taking this point. It's 6 with 30. Okay, or 31 actually. Okay, and what? I will try to find out the answer. So it will be the velocity or the speed equal the gradient, okay, of the tangent, which is equal 31 minus 0 divided by what? 6 minus 2, okay, the y-axis over the x-axis, and the answer will be approximately how much? 30. It will be approximately, where is the calculator? Yes, it will be 31 divided by 4, which is yes, it will be approximately 7.75. So I'll put it 7.8 meters per second. There is range of the accepted answer. The answer actually it's 8 plus minus 0.3. The accepted answer in the mark scheme was 8 plus minus 0.3. So I am in the range of the accepted answer. So I got the 3 marks. Okay. Next. This is part A of this question. Part B, you don't know the Mach scheme, of course. No one knows the Mach scheme, okay? Part B, calculate the acceleration. They told us that it starts from rest and has a constant acceleration. So acceleration equal what? V minus u divided by t. And v is what? Is the final velocity that we just found out. 7.8 minus u, which is 0, divided by the time, which is how long was the time? Not 6, no. The time at this moment, I find the speed at this point after 4 seconds. So divided by 4, and the answer will be 7.8 divided by 4. The answer will be 1.92. That means 2.0 meters per second square, two significant figure, and that's the accepted answer in that year. Easy, 5 marks. That was question number 14. When they said question number 14, that means it's not easy question, because usually question number 11 is the easiest. Then question number 12, it will be a little bit harder. And okay, whenever we go to the number of questions, okay, more than 13, 14, 15, the hardness will increase. Exactly. Okay, yes, what about the multiple choice? Always I'm saying as advice to my student, don't start the multiple choice questions. Start from question number 11 and skip the first 10 multiple choice questions. When you start the question number 11 and you finish the whole exam, then you return back to the multiple choice questions. You can use more time. Why? Because you are entering the exam, you are stressed, you are afraid. Maybe you lose more than 1 minute for each one multiple choice question. But if you start question number 11, okay, you'll find it easy. You'll get more relaxed. Go to question 12. Okay, you go to the rhythm. You'll be fast to answer the questions. Okay, then if you have 10 minutes, okay, you can put whatever you want, okay, on the multiple choice questions. But if you start from the multiple choice questions, not all the students reach the final question. The final 2 questions, maybe more than 30 marks on them. Okay, that means why? Because a lot of students, they spend more than 10, 15, or even 20 minutes in the first 10 multiple choice questions, which is supposed to be only 10 minutes. Okay? Any question? Any questions so far? Okay, so let's return back to Newton's laws of motion. This is Newton's first law of motion. Newton's first law of motion talks about what? Balance objects. Yes, talks about what? Balance objects. So when we talk about Newton's first law, okay, we are talking about what? Balance objects. So when we talk about balance object, yes, hold on. Law of inertia. Yes, law of inertia. Hold on, if you please. There's something wrong here. Hold on. I can't write on this PDF. Okay, there's something on the laptop. Okay, no problem. Okay. خلينا نرجع للشيء البدائي. Okay. When we talk about forces, okay, since we are in the 4th grade, we are start studying talking about forces. Who can tell me what is the force? Who can tell me what is the force? What we use force for? Yes. Thank you. Another answer. That's since 4th grade. Yes, push or pull. So yes, we need the force to push or to pull objects. Then what? These forces, we needed to do one of 2 things. Change the motion of the object, speeding up, slowing down, change direction of motion, cause acceleration. Yes, as we have talked before. Yes. Or change the shape of the object, bending, compress the spring, okay, twisting. So we can use the force to do 2 things. Try, not always do it, okay. Try to change the motion of the object, or try to change what? The shape of the object. Now we are going to talk about the motion here. So we are trying to change the motion. So Newton's first law of object, which we call it law of inertia, okay, law of inertia. What do we mean by inertia? Now I will explain it. Law of inertia حلو كتير. Law of inertia, okay, talks about balanced objects, and we just finished talking about balanced object, and we said that balanced object can be two different situations. What are the balanced objects? Yes, any object at rest, stationary, this is a balanced object, bravo, or any object at what? At steady what? At speed, huh? At steady what? Excellent. At a steady what? Velocity, constant speed and constant direction. So any object at rest, for example, if I have a box, okay, on the table, like my mobile, okay, on the table, on the ground, okay, what are the forces act on this box? What are the forces act on this box? Who can tell me what are the forces acting on this box? Exactly, we have weight downwards, bravo. What else? Weight or gravitational force? Don't say gravity. Don't say gravity. Gravitational force, okay? Or yes, normal reaction contact force upwards. So we have gravitational force downwards, and we have what? Normal reaction what? Upwards. Normal reaction from the ground or from the floor. Normal what? Reaction. Exactly. Okay, now which one is bigger? Which one is bigger? The normal reaction upwards or the weight downwards? Which one is bigger? The normal reaction. You finish IGCSE, are you sure? Okay, yes, they are. Since the object is at rest, they are equal. Exactly. The weight is equal the normal reaction force. That's why, how much is the resultant force on this object? Since it is at rest, how much the resultant force on it? Exactly, zero. So the resultant force on it is zero. There's no, and also the acceleration on it equal how much? It's also equal to zero. Exactly. So this is the first half part of the Newton's first law of motion, which is the object at rest remains at rest unless a resultant force acts on it. So the resultant force acts on it is equal how much? Zero. There is no resultant force. Good. Tamam. The other situation, when the object is moving at constant velocity. For example, this is the road, this is the street, okay, and these are the wheels of our car. Okay, for example, Marwan, okay, he has Lamborghini. هلا حرسم لك أنا أحلى لامبورجيني. كيف حتطلع معي كيا CV? Don't ask me, okay? So which color do you like? Red one? Okay, خلاص. So يا سلام يا سلام الله 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 الله. طيب طلعت موستن. يلا مش مشكلة. Okay. So what are the forces that act on this what? On this car as it moves at constant speed forwards? As the car is moving at constant speed forwards, okay? Equilibrium, yes, equilibrium or balance object. Yes, you can write this down, Samuel. Thank you. Tamam. So we have weight down, as we said now, and we have on the wheels, okay, because it's a horizontal ground, okay, we have equal normal forces on the wheels, and we said that the normal and the weight are equal. Bravo. We have several forces act backwards, okay? What are these forces? We have friction force and drag force, air resistance. Bravo. So we call these forces friction forces or resistive forces. Friction or resistive forces, okay? Tamam. And we have thrust force, exactly, thrust force from the engine forward. Exactly, we have a thrust force from the engine, what? Forwards, okay. Now, which one is bigger, the thrust force or the friction forces backwards? Which one is bigger, the thrust or the resistive forces? The thrust? Are you sure? You just finished IGCSE a couple of months ago. I'm talking about object which move at steady speed, constant speed, it's balanced. So which one is bigger? Exactly. Because the car is moving at constant speed, that means the driver pushed the gas at a certain push, okay? That means that the car does not increase the speed or decreases the speed. If he push more gas, okay, that means the car will accelerate. There is more thrust, okay? If he reduce the gas, that means the car will slow down. That means it will decelerate, but it's moving at constant speed. That means the thrust force forward or the forward forces like thrust equal what? The resistive force is what? Backwards. So that also lead us to the same thing, that the resultant force and acceleration equal how much? 0. This is Newton's first law. Newton's first law states what? Any object at rest remains at rest, and any object at constant velocity remains at constant velocity, unless a resultant force acts on it to make it accelerate or to change that. That means the resultant force acts on it. How much does it equal? 0. It's equal to what? To 0. So this is Newton's first law. Okay, let me write it down. Okay, and we are going to use it to explain it later on in other things. So what it says, any object at rest or at steady velocity, not speed, steady velocity remains the same since there is no resultant force on it. No resultant force acts on it. Acts on it. Tamam? This is Newton's first law in words. Okay, we are going to do other explanation later on about this law. That's why they call it law of inertia. But what about Newton's second law? Write this down. I'll take a screenshot if you want. Okay. Tamam. Okay. Thank you. Now, Newton's second law of motion. They call it law of what? Law of acceleration. That means there is acceleration. If there is no acceleration, the resultant force, it will not be what? Exactly. Thank you, Samir. Okay, Samir or Samir? Samir, okay. Newton's second law, okay, states what? That resultant force equal what? Mass multiplied by what? Acceleration. So what that means? The law of acceleration. It means that the acceleration equal what? Resultant force over mass. That means the resultant force for any object depends directly proportional to the what? And depends inversely proportional to what? Excellent. The acceleration of any object depends directly proportional to the resultant force and inversely proportional to what? To the mass of the object. Okay, so the resultant, what is Newton's second law in words says? Okay, the acceleration of any object, the acceleration of any object is directly proportional to the resultant force. Don't write like this in the exam. You have to write it the whole word, because I'm trying to be fast. To the resultant force acts on it, and inversely proportional to its mass. Okay. How do they bring questions about it? A lot of questions they bring about it. For example, if I have a bus, okay, this is the bus, okay, and we have several forces act on what? On this bus. For example, we have a thrust force forward, which is 5,000 Newton, and we have a friction backwards, 1,000 Newton, and we have air resistance backwards, 500 Newton, and the mass of the bus is 2,000 kilogram. Can we find the acceleration? Can we find the acceleration? Yes, of course we can find the acceleration. Tell me, huh? The resultant force equal mass multiplied by what? Acceleration. So how much is the resultant force? Excellent. The resultant force is the forces forward minus the forces backward. So it will be 5,000 minus, open bracket, 1,500 equal the mass which of the bus, which is 2000, multiplied by what? By the acceleration. So by using calculator, it will be 3,500 divided by 2000, it will be 1.75 meters per second square. Okay, let me check. Okay, divided by 2, yes, it will be 1.75 meters per second square. This is the acceleration. Yes, it's easy. Take screenshot here, if you please. Take screenshot. Now, I will ask a question that they bring it twice. One as a star question and one as brief 2-3 marks question. Okay. Star question, that means yes, 6 marks in the old new syllabus and 4, 5, 6 marks on the old syllabus. But now we are talking about the new syllabus. Which law includes the other? Does the first law include the second law, or does the second law include the first law? That means which law is bigger that include the second one in it? The first include the second, or the second include the first? Send me on the chat. Send me the answer. Think about it and send me the answer. Which law includes the other? Does Newton's first law include the second, or does the Newton's second law include the first? Yes. Good. Okay, another answer. Tamam. It seems that you know the answer. No, some of you did write the wrong answer. Some of you, they said both of, includes both of the other. ايش هذا الجواب? Okay. Okay, good. ماشي. Actually, Newton's first law, it's one situation of a Newton's second law. Newton's first law, it's a situation when the acceleration equal how much? When the acceleration equals 0. So when the acceleration is 0, that means mass multiplied by 0 make the resultant force equal how much? 0. That means Newton's second law includes Newton's first law. Okay? How? There's more details about the explanation, but yes, in Newton's second law, because it has about all situations of acceleration, one of these situations, when the acceleration is 0, that means the object, it will be at rest or at a steady velocity. That means the resultant force equals 0, because mass times 0 acceleration, which makes resultant force equal 0. That means the forces are balanced. So Newton's second law includes Newton's what? First law. Thank you for all the people that they answer. That's it for today. يعطيكم العافية. If you have any question, you can send me on the chat. Okay, my number again is 962-7998-28524. This is Dr. Ahmad Al Faris. يعطيكم العافية. If you have any question, you can stay online. If you don't have, you can leave. Have a nice night. Assalamu alaikum.